The chemical reactivity of an atom is based on the number of electrons the atom contains in its outermost electron shell. Electron shells are depicted here as circles around the nuclei of the atoms. Each shell contains electrons with particular energy levels. Let's examine the electron shells of the element argon. The first electron shell holds just 2 electrons. These are electrons at the lowest energy level, the shell that electrons of an atom fill first. The next 2 shells can each hold 8 electrons. Argon's third and outermost shell is already filled to capacity, making this element extremely unreactive or inert. Chlorine also has electrons in 3 electron shells, but its third shell contains only 7 electrons. In chemical reactions, chlorine has a tendency to gain an electron, filling this shell with 8 electrons. This tendency to fill the outermost electron shell with 8 electrons is known as the octet rule. Sodium has electrons in 3 electron shells, but its outermost shell contains just 1 electron. Sodium cannot receive 7 additional electrons to complete this shell. This would require a huge amount of energy. Instead, sodium has a tendency to lose its outermost electron, leaving this atom with 2 filled inner shells. In general, elements with filled outer shells are inert, but atoms of all the other elements are chemically reactive and can form chemical bonds with other atoms. A chemical bond is an attractive force between atoms. Bond formation relies on the ability of atoms to share, donate, or receive electrons from other atoms. Let's examine the nature of a chemical bond using hydrogen atoms as examples. 2 atoms are depicted with their electron shells. 2 others are depicted more realistically, showing a region of space around the nucleus where the electron has a high probability of being found. This region is an electron's orbital. If 2 hydrogen atoms approach each other, the positively charged nucleus of one is attracted to the negatively charged electron of the other. The orbitals merge, and the electrons are then equally attracted to and shared by the 2 nuclei. The electron-rich region between the nuclei binds the atoms together.